Hi, everyone. For this assignment, I'm going to talk about my two key highlights from the readings on constructivist learning in mathematics and how they connect to conceptual and procedural knowledge. So, the first highlight comes from Thompson's chapter on constructivism. On page 2, he quotes von Glassefeld saying that knowledge is not passively received, but actively built up by the learner. What that means is you can't just pour math into kids and expect it to stick. Every student is constructing their own understanding based on what they already know. Riddle Johnson and Schneider back this up. On page 1, they define conceptual knowledge as comprehension of mathematical concepts, operations, and relations. And on page 2, they point out that novices, like our students, only have conceptual knowledge that is often fragmented. It's not fully connected yet. It takes time to integrate. So, the key takeaway here is when a student gets something wrong, it's not because they're not trying, it's because their brain is still building the pieces, and that's normal. Highlight 2 is about how concepts and procedures actually relate to each other. Riddle, Johnson, and Schneider say on page 6 that the most accepted view today is the iterative view. Conceptual and procedural knowledge are bidirectional. Each one helps the other grow. Understanding the concept helps you get better at the procedure, and practicing the procedure helps you understand the concept better. And Thompson adds some important context on page 2. He talks about how constructivism grew out of a rejection of behaviorism, the old drill and kill approach where only the right answer mattered. Constructivism shifted the focus to actually caring about how students are thinking. So the bottom line, don't teach concepts first, then procedures, or procedures first, then concepts. They grow together. So here's a visual of where I see this play out in my own classroom. I teach 8th grade math to advanced 7th graders, and one topic we cover is dilation. Students pick up the concept pretty quickly. Dilation makes a shape bigger or smaller. That's on the conceptual side. But then I give them a problem with scale factors like 7/8 and 8/7, and they freeze. They don't know which one's the enlargement and which one shrinks the shape. That's the procedural side. Multiplying by fractions isn't solid yet. The overlap is where we want them to be. Knowing that 8/7 is greater than 1, so it enlarges, and 7/8 is less than 1, so it reduces. But a lot of students are stuck in one circle without connecting to the other. So, why does this matter? First, I chose two highlights because they work together. Highlight 1 explains why students struggle. They're actively constructing understanding, so of course it's going to be incomplete sometimes. Highlight 2 explains how to help. Treat concepts and procedures as partners, not opponents. In my classroom, when I see students mixing up 7/8 and 8/7, I don't just mark it wrong and move on. Instead, I sequence the practice so the pattern is visible. Start with the scale factors of 2, 3, 1/2, 1/3. Clear cases where bigger is an enlargement and smaller is a reduction. Then gradually introduce the trickier fractions. That way, students can build the connection themselves. That's what constructivism looks like in practice. It's not about the drilling harder, it's about designing experiences that let students construct the connections.